Recording in
Okay, so I'm going to go over the Unit 6 study guide. And the reason this make a list of the perfect squares and perfect cubes is so that when you're simplifying, you would just have that to use as a pretty quick reference. So your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. And so then your perfect cubes, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, 5 times 5 times 5 is 125, 6 times 6 times 6 is 216. And let's see, 7 times 7 times 7 is actually is 343. And 8 times 8 times 8, 8 to the third power is 512, and so on. Okay, so anyway, you really don't have to have that, especially if you are going to use your TI-30 calculator. And so to simplify 40x squared, well, of course, if I put that in my, and then that is going to be 2 on the square root of 10. Okay. Let me turn the lights on because I think it's too dark in here. Yeah. Okay, that helps. So we have 2 on the square root of 10. And then the square root of x squared is x. And then y is not a perfect square. So it's going to be 2x square root of 10y. All right. And then we have 88. And 88 would be 8 times 11. And 8 is 2 times 4. And 4 is 2 times 2. So I have a pair of 2s. So I'm going to pull that out. Okay. X to the 4th. X squared times x squared is x to the 4th. Y3 times y3 is y6. And then is z, if you've got 3 z's, you have 1 pair of z's. So you just pull that 1 z out. And that's going to be onto the square root of, okay, I pulled out a pair of 2s. And then left over, I have 2 times 11 is 22. And I have a z also left over. So that would be the square root of 88. If I do that on my calculator, see, I get 2 square root 22. So the 2 comes out and the 22 stays under. And then x squared, y3, z, and I had a z left over. All right, the cube root of 216. Well, the cube root of 216 is, that's 1, 2, 3, 4, 5, 6. Cube root of 216, I don't know why I wrote the radical sign, is 6. And then x3, the cube root of x to the third is x. So then the answer to that is just 6x. Okay, -5 square root 6 minus 7 square root 6. Those are like radicals. So then you just add those together and you get -12 square root 6. Okay, the square root of 18 plus the square root of 72. Well, the square root of 18 is 3 square root 2. And the square root of 72, 72 is 36 times 2. So that's going to be 6 square root 2. And now those are like terms, and you get 9 square root 2. All right. Square root 3, subtract 5 square root 12. Well, 4 times 3 is 12. So that would be 2 square root 3, and you would multiply 5 times 2. So that would give you a total of 10 square root 12. 10 square root 3, my bad. And so, look, if you have 5 square root 12, that's 10 square root 3. And then 1 square root 3 minus 10 square root 3 is negative 9 square root 3. All right, also, you can just type that straight in the calculator like that as well. Square root 3, come outside of your square root, subtract 5 square root 3. Oh, I know what I did wrong. That was supposed to be a 12 right there. Square root 3 subtract 5 square root 12 is negative 9 square root 3. Okay. Square root of 40 times the square root of 12. So you could just multiply 40 times 12 and you get 480. And then simplify the square root of 480. And that would be, oh my goodness. See, well, I'm going to show you another way to do it too. But that would be 10 times 48. That's 2 times 5. That's 2 times 24. 2 times 12. 2 times 6. And 2 times 3. All right, you got a lot of pairs of 2s. There's a pair of 2s. And there's a pair of 2s. So that would come out. 2 of your 2s comes out. And then you have left over 2 times 5 is 10. And 10 times 3 is 30. 4 square root 30. All right, so let's just type it straight in the calculator. Square root 40 times the square root of 12. 4 square root 30. You could have also done this way. 4 times 10 is 40. So that would be 2 square root 10. And then the square root of 12 is 4 times 3. That would be 2 square root 3. All right, now look, 2 times 2 is 4. 10 times 3 is 30. That would have been the easiest way to do it if you were working it out. Okay, so this is square root 5 times the square root of 30. And that's going to be 5 times 6 and 2 times 3. So that won't simplify. So you just have the square root of 150. And then you see if that'll simplify. That's 10 times 15, 2 times 5, and 3 times 5. So you have a pair of 5s. So that's going to be 5 onto the square root of 6. All right, and again, square root 5 times square root of 30, 5 square root 6. And you'll have your calculator tomorrow you could use. All right, the square root of 16 is 4. So that's just going to be 4 onto the square root of 2. All right, the square root of 16 divided by 8. 16 divided by 8 is 2. So that's just square root 2. Now, I can't divide this one and like I did that because this one is not under a radical. So I'm going to simplify the square root of 48, which is going to be the square root of 48 is 4 square root 3 divided by 4, and my 4's cancel, and I just get square root 3. But if I typed it in, square root of 48 divided by 4, it will give me square root 3. All right, and then 1,260 divided by 5 is 252. And then the square root of 252 is 6 square root 7. Because 49 times 6 is, 36 times 7. 36 times 7 is 252. And the square root of 36 is 6. So you get 6 square root 7. Okay, so just remember, you can, of course, use your calculator on this section, which I probably shouldn't let you, but, all right, so now this is going to be writing from exponential form to radical form. Remember, the denominator goes out here, and that would be the 4th root of 16, which actually is a perfect 4th root. And that would be fourth root of 16 is 2. So that would actually evaluate to 2. Okay, a to the 2/3 power. So that's my number that goes on the outside, 3. And then I can put my square right there, or I could have written it the 3rd root of a squared. Both of those would be correct. So you take the 3rd root of a squared or the 3rd root of a squared. Okay, this would be the square root of 2y to the 5th, or the square root of 2y to the 5th. Either of those would work. So the square root, the square goes on the outside, and you could put a little 2 there if you want to, but it's just understood if you don't, and then 5th power. All right, 5x to the negative 1/2 would be 1 over the square root of 5x. Because negative makes me put it in the denominator, and 5x to the 1/2 would be the square root of 5x. Right, in exponential form, the 3rd root is the same thing as 1/3 power. Okay, this says 7x to the 3/4 power. Okay, this says 12a to the 3rd to the 1/2 power. So all of this to the 1/2 power. Or you could say 12 to the 1/2, a to the 3/2. 12 is to the 1/2 power, and a is to the 3/2 power. See, there's an understood 2 out here. Let me zoom in a little bit. Okay. All right, and then this is just going to be 10 to the 5/4 power. All right. Now, the next section is solving the equations. And so you're trying to solve for x. So what you want to do first is isolate the square root. And to do that, you want to subtract 4 on both sides. And so you get square root 5x minus 1 equals 7. Now, what is the opposite of a square root? Well, you square. So if you square a square root, that cancels out and leaves you with 5x minus 1 equals 49. Now you're just going to add 1 and divide by 5, and x equals 10. Add 1, you get 50. 50 divided by 5 is 10. And then you want to check for extraneous solutions. What does that mean? That means plug your answer back in and make sure it works. So that would be the square root of 5 times 10 is 50. 50 minus 1 is 49. And then add 4. Does that equal 11? And it does. So 10 times 5 is 50. Subtract 1. Probably should have done that a long time ago. Look how good that looks. I clicked the focus button. Okay, so now, like, if you saw this as 1 minus 2x equals 5, like, pretend that this entire thing hang on, somebody knocking on my door. Hey, sorry, I'm doing a video. Yeah, I'm just doing. Yeah, because otherwise I feel like I'm talking to myself anyway. It's when I do these videos. Allie's in here chilling. Okay, so if you had that, see, I'm just like talking to myself. It's the way I do it. So you would subtract 1 on both sides and then divide by -2. Okay, so that kind of just gets you your idea of where you're supposed to start. Subtract 1. That's -2. M plus 12 equals 4. Okay, so then divide by -2. And you get square root m plus 12 equals -2. And then at that point, you might notice that that is impossible because you can't take the square root of something and get a negative. But if you kept going and you squared both sides, you would get m plus 12 equals 4. M equals -8. And then when you plug -8 back in, you get 1 minus 2 times square root of -8 plus 12 is 4. Does that equal 5? 1 subtract 2 times 2 is 4. And that equals -3, not -5. So that means it was an extraneous solution. And since you don't have another choice, no solution. All right, so number 23, that is 9a plus 45. The 1/2 power just means square root of all of that. So you're just going to square both sides. 3 squared is 9. And that cancels out the square root. A square cancels out a square root. So 9a plus 45 equals 9. Subtract 45. And 9a equals -36. A equals -4. Okay, number 24, square both sides. And you get 3n minus 27 equals 43 minus 2n. So I'm just going to add 2n to both sides. I get 5n. And then add 27 to both sides. And I get 70. N equals 14. 70 divided by 5. Okay. All right, so then number 25, that's 18 plus 7k. Square root of that equals k. And we're going to square both sides. So k squared equals 18 plus 7k. Move all of that stuff over to the other side. And 0 equals k squared minus 7k minus 18. And that factors to -9, +2. And then when you set those factors equal to 0, you get k equals 9, k equals -2. And then we're going to check it. So if I plug in 9, I've got 18 plus 9 times 7, 63. Square root of that, does that equal 9? So square root of 18 plus 63 is 9. So yes, that's square root of 81, and that equals 9. So yes, so k equals 9 works. And then -2 would be 18 plus 7 times -2. So the square root of 18 minus 14 is 2. And 2 doesn't equal -2. So that one's extraneous. So it doesn't work. So your only solution is 9. Okay, number 26, you're going to add 4. And that would give you the square root of 6x plus 19 equals x plus 4. And then you square both sides. And that's 6x plus 19 equals x plus 4 times x plus 4 is x squared plus 8x plus 16. Oh, you can't see that. Sorry. You got to FOIL that. Okay. And then move the 6x over, move the 19 over, and you would get 0 equals x squared plus 2x minus 3. And that's x minus 3, x plus 3, x minus 1. And then that would give you -3 and +1. So you had to factor that. What multiplies to give you -3 and adds to give you 2. Right now, I'm pretty sure that both of these worked when we checked them earlier. Let's see. That would be the square root of, let's plug in -3. Square root of 6 times -3, that's -18 plus 19 is 1. Square root of 1 is 1. And 1 subtract 4 is -3. So that worked. And then if you plug in 1, you get square root of 6 plus 19 is 25. Square root of 25 is 5, and 5 minus 4 is 1. So that one worked too. So that one had 2 answers. And that means that it's going to cross the x-axis at those 2 numbers. The reason why some of them are extraneous is because they will, you solve and get it, but then square root is not going to be, it's not going to be, you're not going to be able to cross the x-axis at that number. It would be like undefined or whatever. So anyway, all right, that's TMI. Okay, so then these are the transformations of the square root graph or a cube root graph. So 3/4, a fraction in the front makes it compress, and the +1 on the outside makes it go up 1. The 2 here makes it stretch. +5 on the inside makes it go left 5, and -8 makes it go down 8. All right. This one is the cubic parent function. Okay, so that means I know that it's going to be the cube root, cubic. Huh. Cubic. Does that mean third power? Or do they mean third root? I mean, I would have said the cube root parent function. I mean, that's what we've been doing, but cubic to me means third power. Cubic is third power on number 29. I just think, I mean, I was just expecting it to be cube root. I guess, did they mean cube root?
You did that one in class.
Yeah. Did I do the cube root?
Mhm.
Yeah, I just now read more carefully. So anyway, it's going to reflect, and then it's going to go left 6, down 2. So anyway, that would be reflect, left 6, down 2. What I was talking about was I was wondering if it was supposed to be third root or third power, because cubic to me means third power. But we've been doing, this whole unit is on square root and cube root. So I think they meant to put cube root parent function. All right, so let's talk about these graphs. What you want to do, or I mean, I first just kind of think about what it should do based on the transformations. I mean, that's going to make it go down 7. So that means the square root graph, okay, there's the square root parent function. It's just going to shift down 7, and it's just going to do like that. But it's also going to stretch a little bit. So that means it's going to be a little bit skinnier. All right, so my end point is 0, -7. So that's my end point because it went down 7. All right, now that means I'm going to start my chart at 0, -7, and then I'm just going to get larger. I'm not even going to do smaller because I can't, that would be undefined. The square root of -1 is imaginary. So probably what you're going to do at this point is put it in the calculator and go to the table. So you have 4 square root x, come outside and subtract 7. And there's the graph. You can see it started. And then your table. See how it's an error at all those negatives? Because that would be a negative square root. So then you got 1, -3. And then 4, 1. And then if you keep going, 9, 5. Okay, so we're 0, -7, 1, -3, 4, 1, and 9, 5. See how that 4 stretched it? It made it get closer to the y-axis. A compress would make it get closer to the x-axis. All right, so the domain, remember, domain is the left boundary to the right boundary. So the left boundary on the x, domain is your x, the left boundary on the x is 0. And the right boundary, it goes all the way to positive infinity. All right, and then your range is the lowest point to the highest point on the y. So the lowest point on the y is -7, and the highest point, it goes up to infinity. All right, to get these two like separated in your mind, think about that end behavior is what is it doing on the ends, and you use y values when you're doing these two right here. This is always going to be negative infinity and positive infinity. I don't know why they didn't go ahead and fill that in. As x goes to negative infinity, as you go left, as you go to the left, what does this graph approach using a y value? As you go to the left, this graph approaches -7. As you go to the right, this graph goes up forever to infinity. So it approaches on the left -7, and on the right it keeps going up to positive infinity. And then your increasing intervals are x values, and your decreasing intervals. Well, first of all, this is never decreasing. It's going up all the time. And so using your x values, that means not -7, but on the x, this graph increases from 0 to forever. So it increases on the x from 0 to infinity. Just make sure you use x values for increase, decrease intervals, and then these numbers right here are going to be your y values. All right, so then the next one, I'm like, okay, this one goes left 6, and it goes up 5, and it's going to flip. Just so I know that I'm kind of thinking about it from the get-go. It flips, left 6, up 5. So left 6, up 5. And that's going to be the endpoint, left 6, up 5. Okay, so then that's going to be the first, that's my endpoint. So that's going to be my first numbers in my XY chart. So I got negative square root x plus 6 plus 5. See, it's going to flip. Okay, so then I go to my table, and I'm going to start at left 6, up 5. And then I got -5, 4. And -2, 3. And 3, 2. -5, 4. -2, 3. 3, 2. Okay. All right, so my domain, remember, that's left to right. The left side, the far left side is -6. And the far right side is infinity. Or, yeah. Then the range, the lowest point is negative infinity, because this is continuing to go down, even though my graph doesn't really look like it. It continues to travel downward. And then the highest point is on the y. Remember, on the y, it's 1, 2, 3, 4, 5. Okay. As x goes to negative infinity, the graph approaches remember, on the y, this is my y. As x goes to negative infinity, the graph goes to 5. As x goes to positive infinity, the graph is going down to negative infinity. So as x goes to positive infinity, y goes down to negative infinity. All right. And it's never increasing, and it's always decreasing. This is on the x axis, on the x from -6 to infinity. This graph is always decreasing from here forever. All right, now the cube root graphs, okay, this one's just going to go right 1. Okay, so that means that my point of inflection is 1, 0. 1, 0. And when I make my XY chart, you see, cube roots can be negative. So I'm going to put 1, 0 right in the middle of my chart. Right? And y equals, right, cube root is math, and then cube root x minus 1. So I can go ahead and graph it and kind of see what it's going to look like. And then go to the table. And so I've got 0, -1, 2, 1. Go up to the next whole number. -7, -2. Go the other way after 2. I mean 9, 2. Okay. So that's going to be 1, 0, 0, -1, -7, -2. And then 2, 1, 9, 2. Okay. All right. On these, your domain and range are going to be all real numbers because it's going left and right forever and up and down forever. As x approaches negative infinity on the left, the graph goes down to negative infinity. Y goes down as you go to the left. As you go to the right, x goes to the right to infinity. The graph goes up to infinity. The graph is never decreasing. It's from left to right, its altitude's always climbing. So it's always increasing. Okay. And then number 33 is it's going to compress. So it's going to be a little bit flatter. And it's going to go left 3, down 5. So left 3, down 5 means my point of inflection is going to be -3, -5. And I'm going to put -3, -5 in the middle of my table. Okay. And then I'm going to put this in the calculator. We got 1/2 cube root. Remember, that's math number 4. Cube root x plus 3. Come outside, subtract 5. Okay, so see, it's really flat. It's almost a straight line, but it's not. All right, and then the table would be negative, let's see, -3, -5, and then, oh, well, -11, 6, -6, and then 5, -4. Okay, so 5, -4. It's right there. And then 11, -6 would be like right here. There's 10 boxes. All right, so see, it's really flat. The reason is because of that 1/2 that we multiplied by. All right, we got all real numbers for our domain and range. As x goes to negative infinity, y goes down. As x goes to positive infinity, y goes up. it's always increasing and it's never decreasing. Okay. All right, now inverse functions, find the inverse. So you're just going to switch your x's and your y's. And this one's not a function. This one is a function, but they have to both be functions for it to be one-to-one. So this is not one-to-one relationship, a one-to-one function. Okay, that's switch my x's and my y's. Okay, and okay, no x is repeated here, and no x is repeated here. So yes, it's one-to-one. All right, now you just, if they pass the vertical test and the horizontal test, then they will be one-to-one. So this one passes the vertical test and the horizontal test. So yes, this one passes the vertical test, but then right here, it does not pass the horizontal test. This one passes the vertical test, but not the horizontal test. So it's not one-to-one. Okay, number 39. So what you're doing on 39 and 40 is just proving that inverses are symmetrical or mirror images across the line y equals x. So if they mirror each other across y equals x, then yes, that's what you're trying to prove. So the regular function is x plus 7. So we go to 7. And then the slope is 1. So slope of 1, y-intercept 7. And that wasn't a great line, but anyway. All right, so there's that line. And then the inverse is going to be, I mean, I already know it's x minus 7, but I'm going to go through the steps. So that's y equals x plus 7. Switch the x's and the y's. Subtract 7. X minus 7 equals y. So then my y-intercept is negative 7. And then my slope is 1. So then, yes, those are mirror images. They're the same distance from y equals x. Okay, so then if I graph number 40, I've got the square root of x plus 3. So that means it was just basically the square root graph up 3. All right, so square root x plus 3. All right, so I have 0, 3, and then 1, 4, and then 4, 5. And my next point was 9, 6. All right, so that graph does that. Square root graph shifted up 3. Okay, so then the inverse, y equals square root x plus 3. Switch your x's and your y's and solve for y. So we're going to subtract 3 on both sides. That's x minus 3 equals square root y. Square that, square that. So x minus 3 squared equals y. All right, the reason I'm not going to like FOIL that and put it in standard form is because it's in vertex form. So that just tells me that it's the square, it's the quadratic graph, and it just went right 3. So that's the good thing about it already being in vertex form. Remember, vertex form is that. So then I looked at that and went, oh, well, it's just a parabola that was to the right 3. So that would be my vertex is to the right 3. So then if you do y equals x minus 3 squared and go to your table, you got 3, 0, and then 4, 1, 5, 4, 6, 9. See that right there? Okay. If I did the other side, I didn't really put this on here, but I should have put when x is greater than or equal. I should have put x is greater than or equal to 3. I just didn't put that stipulation in there. But if we did graph the other side, you'd have this right here, and it would, it would do that. So basically, we're kind of ignoring everything in the parabola that's less than 3. And that's, you can see it's symmetrical right there. Was that all of it, or was there another sheet? That was all? Okay. All right. So I'm pretty sure I'm going to let you use this study guide on the test because it's just been so crazy this week and everything. So yeah. All right. Peace out.